Good morning, students. How are you all? So, welcome to your physics class. So far, we have discussed reflection. Now, today, we will be starting with the next topic, that is refraction of light. Earlier, also, I told you that the basic difference between reflection and refraction is that reflection is the bouncing back of the light in the same medium. But what will happen when a ray of light travels from one medium to the other? We know that light rays follow the property of rectilinear propagation. That is, light always travels in a straight line, right? But when a ray of light travels from one medium to the other, now what do we understand by a medium? Medium can be any substance through which a light is traveling. Medium could be air, it could be water, or even a slab of glass. In this chapter, we will see that when light travels from one medium to the other, it does not follow a straight line path, and a bending of light takes place. Now, this bending of light depends that whether a ray of light is going from a rarer to a denser medium or from a denser to a rarer medium. Now, what are rarer and denser medium? Rarer, as you can make out from the name only, that is, it is having rare number of particles. That is, an optically rarer medium is that which is having less number of particles per unit volume. Whereas a denser medium is that which is having more number of particles per unit volume. Like we can say, water is denser than air, glass is denser than air, oil. What about oil and water? We know that oil has got less density as compared to water, that is why it floats on the surface. Now, when we talk about optical density, the bending of light when it goes from one medium to the other depends on the difference in densities of the two medium, because speed of light is different in different medium. So this bending of light actually occurs because of the difference in speed of light. So you can make a guess now. When a ray of light is going from a rarer to a denser medium, naturally the speed of light will decrease. So as a result, it bends towards the normal. Similarly, when a ray of light is going from a denser to a rarer medium, in that case the speed of light would increase and it would bend away from the normal. First of all, what is refraction? When light travels obliquely from one transparent medium to another, it gets bent. This bending of light is called refraction. Or as per the definition which we had written, it is phenomenon of change in the path of light while going from one medium to the another. It is phenomenon of bending of light from the original path on entering another medium. This bending or refraction occurs at the boundary or the interface of two media. Here, light travels obliquely from one transparent medium to the another and it gets bent. Okay, like we can see here in a diagram also, where here we have a surface which is separating two medium. This surface which separates two medium is called as interface. Bending of light always takes place at the interface, that is the boundary separating two medium. So suppose this is our medium 1 and this is our medium 2. This is our incident ray. Okay, this is our incident ray. Like in our labeling, we had named it AO. Now, we see that the ray should have followed this straight line path, but it does not, because now it is going from one medium to the other medium, and these two mediums have different densities. So the ray of light refracts, it bends. In this case, now the ray of light is going from optically rarer to denser medium. That is why it bends towards the normal. In the second case, when a ray of light is going from a denser to a rarer medium, it bends away from the normal. It bends, this ray this ray bends away from normal. Okay, so when light travels from a rarer to denser medium, it bends towards the normal, and when it travels from a denser to rarer medium, it bends away from the normal. Once again, what is refraction? Refraction is the phenomenon of bending of the light when it travels from one medium to the other. What is the cause of refraction? Cause of refraction is the change in speed of light while going from one medium to the other. When light travels from an optically rarer to a denser medium, in that case the speed of light decreases. Like the first case, here a ray of light is traveling from an optically rarer to a denser medium. So as a result, the speed of light decreases and it bends towards the normal. The light has not followed straight line path, but it has bent towards the normal. In second case, when a ray of light is traveling from a denser to a rarer medium, now the speed of light increases, and that is why it bends away from the normal. Okay, so in both the cases you can see I, which was called the angle of incidence, and R, which was called the angle of refraction. Angle of refraction here is the angle which the refracted ray makes with the normal. Similar in the second diagram, I, which is the angle of incidence, angle between incident ray and normal, and R, which is the angle of refraction, that is angle between refracted ray and normal. Both the diagrams you can see angle of incidence and angle of refraction are never equal in case of refraction. Like in case of reflection we had done, angle of incidence and angle of reflection are equal. But in case of refraction, angle of incidence is never equal to angle of refraction. Either angle of refraction is smaller in than angle of incidence, as in the case of ray going from rarer to denser medium, or angle of refraction is greater than the angle of incidence, as in the case of ray going from an optically denser to a rarer medium. Okay, after that, some daily observations where we find refraction of light to take place, like if you dip a pencil in a glass of water, you will find that it appears to be bent at the interface. That is, the pencil does not appear to be straight in water, it appears to be bent at the interface of air and water. Similarly, a coin appears to be raised when dipped in a glass of water. A lemon also appears to be of different size when dipped in glass of water. That is because in all these cases, a ray of light when coming from water to air will be traveling from optically denser to rarer medium. So as a result, bending of light takes place. A water tank appears to be shallow when observed from outside, again because of refraction. That is, the depth which is visible from outside is less than the actual depth of the tank. The depth which you see or which appears from outside, that is called the apparent depth, and that is always less than the real depth. So, refraction is a phenomenon which we can observe in our daily lives, and that is because of the bending of light while going from one medium to the other. So, the cause of refraction we have already discussed, that is because of change in the speed of light while going from one medium to the other. Like speed of light in air. In air, we take the speed of light as 3 into 10 raised to power 8 meter per second. Speed of light in glass is 2 into 10 raised to power 8 meter per second, and speed of light in water is 2.25 into 10 raised to power 8 meter per second. So you can see that the speed of light is different in different media, and because of this difference only there will be bending. Greater the difference in speed of light in two media, greater will be the bending of light. That means here bending of light would be more when light travels from air to glass. as compared to light traveling from air to water, because the difference in speed of light is more as it travels from air to glass as compared to difference in speed of light while traveling from air to water. Next property which we are going to read related to refraction is the refractive index. A refractive index, also called as absolute refractive index. A refractive index is a property which is related or which is characteristic of every medium. Okay, refractive index can be defined as a ratio of, it is denoted first of all by symbol n. It is defined as ratio of speed of light in vacuum to speed of light in medium. Medium means whatever medium we are talking about, that can be air or water or glass. So refractive index is denoted by symbol n. Speed of light in vacuum or in air denoted by symbol c, and speed of light in medium denoted by symbol v. So this is the formula for refractive index, n is equal to c divided by v. Suppose I tell you what is refractive index of water. W subscript have written for water. So that will be equal to ratio of speed of light in vacuum or air divided by speed of light in medium, that is denoted by V. Putting the values now, 3 into 10 raised to power 8 speed of light in air divided by speed of light in water. What is that? That is 2.25 into 10 raised to power 8. If you simplify it, 300 by 225, solve, it comes out to be 4 by 3. So this is refractive index of water, which is 1 point something. Refractive index, since being ratio of two similar quantities, it has got no unit. Okay, so refractive index is a characteristic property of medium whose value depends on the nature of material. Refractive index of air, of water, of glass, all will be different. So refractive index, which is the characteristic property of the medium, is defined as the ratio of speed of light in vacuum to speed of light in medium, given by formula n is equal to c divided by v. If we talk about air, what would be refractive index? That would be 1, right? Because refractive index for air, that is c by v, both of them have value same, that is 3 into 10 raised to power 8 in case of air. So if we talk about refractive index of water, that is c by v. C is speed of light in vacuum, 3 into 10 raised to power 8 divided by 2.25, 10 raised to power 8, which is speed of light in water. You take the ratio, it comes out to be 4 by 3. So similarly, you can be asked to tell refractive index of any medium. There is a table related to it which is given in your NCERT book. You can go through that table once. Okay. Next topic for today is relative refractive index. Relative refractive, relative as you can make out from the term, is comparison of refractive index of the two medium. Now suppose a ray of light passes from medium 1 to medium 2. Then we write it as n21, that is refractive index of medium 2 with respect to medium 1. What is n21 here? That is a refractive index of medium 2 with respect to medium 1. n21 would be written as n2 by n1, right? Refractive index, we are talking about a ray of light going from medium 1 to medium 2. So we are talking about refractive index of medium 2 with respect to medium 1, that is written as n21. n21 is written as a subscript, that means n2 by n1. But what is n2 here? N2 will be c by v2. What is v2 here? That is speed of light in medium 2. Similarly, n1 is c by v1. Here again c by v1, where v1 is speed of light in medium 1, right? If we put these values, let this be equation 1, this be my 2 and 3. If I put 2 and 3 in 1, and 2 1 would become c by v2, c by v1. If it goes in numerator would reverse, c gets cancelled. So n21 can be written as v1 by v2. n21 can be written as ratio of refractive index of second medium with respect to 1, or reverse of the speeds, that is v1 by v2. Let's see it once again. Ray of light is going from medium 1 to medium 2 here. A ray of light is going from medium 1 to medium 2 here. So n21, which is refractive index of medium 2 with respect to medium 1, would be written as n21. That is n2 by n1. n2 is refractive index of medium 2. That is c by v2 as well as per the definition of refractive index. Similarly, n1, that is refractive index of medium 1, would be c by v1. We put these two values, equation 2 and 3, in our 1. So n21 becomes c by v2 by c by v1. Goes in the numerator, reverses, c and c gets cancelled. So n21 is v1 by v2. So refractive index of medium 2 with respect to medium 1 is n2 by n1 or v1 by v2. Then can you tell me what would be n12, refractive index of medium 1 with respect to medium 2? That would be n1 by n2 or v2 by v1, reverse of this, right? So this is how we write refractive index of one medium with respect to the other. So we can calculate a refractive index of air with respect to water, or water with respect to air, by using the same formula. Okay, so what all have we discussed today? First of all, we talked about refraction, which is the bending of light when it travels from one medium to the other. The cause of refraction is the bending of light, or the cause of bending of light while going from one medium to the other is because of change in the speed of light. When the speed of light increases, as a result, the light would bend away from the normal, as happens when a ray of light goes from denser to rarer medium. When a ray of light travels from rarer to denser, as the speed decreases, so the ray of light would bend towards the normal. Angle of incidence and angle of refraction are never equal. Either angle of refraction would be greater than the angle of incidence, or would be less than the angle of incidence. That means that the laws are no more applicable in case of refraction, that angle of incidence and reflection are equal, is not applicable in case of refraction of light. After that, we read about refractive index. Refractive index is defined as the ratio of speed of light in vacuum to the speed of light in medium. It is written by symbol small n, that is c by v. Since it is ratio of two similar quantities, that is ratio of speed, so that is why it has got no units. Then we talked about relative refractive index. Relative refractive index is when a ray of light is going from one medium to the other. We are writing refractive index, suppose, of medium 2 with respect to medium 1, n21. That would be written as n2 by n1. But n2 is c by v2 as per the definition, and n1 is c by v1. Here v2 and v1 are the speed of light in medium 2 and 1 respectively. Putting those values here, n21 comes out to be v1 by v2. Similarly, we can write n12, refractive index of medium 1 with respect to medium 2 is n1 by n2 or v2 by v1. Okay, so that's all for today. Next time we will be discussing about refraction through a glass slab and spherical lenses. Thank you so much.